So today, let's continue our discussion on decision tree. So last time we were using the cardio dataset. Okay, so let's have a quick review of this. So cardio is a dataset consisting of, consists of saan na si cardio natin? View ko nga. Yeah, it's already here. Let me just get the structure. Okay, and the summary. Okay, 22 variables all in all, 2,126 observations. Okay, and what we said was yung last variable natin yung NSP. It's an integer, but it actually represents 1 for normal, 2 for suspect, P for pathologic. Okay. Pathologic, and we want to convert that as a factor. So the code that we use is the object cardio. Okay, we created an object, a variable cardio NSP PF as factor cardio NSP. So this just creates another variable NSP factor. Okay, so let's run this. I'll run that. I hope, guys, that you have already run that. So I'm just doing a quick review. Okay, so we now have 23 variables because we created this NSPF, which is a factor there. Factor with 3 levels. 1, which is normal. 2, it's suspect. And 3, pathologic. Okay. So we said, guys, that in machine learning, it's not good to model all your data, all respondents. What we do in machine learning and even in other statistical analysis is to split the data. We partition the data so that you have two classes now. You have now a data that you can use for training and another data that you can use for testing. So so that we have the same data, what we did was to set that seed and then create an object called partition data PD, where we have 2 samples, okay, from the rows of cardio. Replace is equal to true, which means that it's just like from a container. You have the data, you get a sample, then you can return the sample. Okay, probability is equal to 80% for the first one and 20% for the second partition. Okay, so we did this last time. Okay, so let me do this because I haven't run this. The data has already been lost. So this is our PD, partition data. Okay, so ito siya, no? It means that observation 1 up to observation 4 were all marked part of the first group. Observation 5, observation 14, 16, etc. Second group. So there are all in all okay, so we are now separating. We're now creating an object called train. Okay, and that's coming from the cardio data set. And then the rows, guys, the rows that will belong to train will be those that are from the index equal to 1. Okay, and then validate for all the items, for all the rows in the cardio object that are indexed as number 2. Okay, so let me run this. Okay, a question lang, guys. Have you run this before we started? If not, guys, kindly run them. so that we have we're doing this together. If you have, that's good. So the parentheses here, guys, will print the result, train and validate. So if you don't really want to have it printed here, don't include the parentheses at the beginning and the end. Just maybe best to use view, train, view, validate to create a data frame in a tab. Okay, thank you. All right, good. Thank you, David. Okay. All right, then we're going to use the party package in order to create a decision tree. Okay, so we said that decision trees are used for for prediction. Okay, the data, what we're predicting can be a numerical variable, okay, or a categorical variable. Okay, so in this case, we're predicting the NSPF factors, the N, the S, and the P from the variable NSPF of the cardio from the cardio object, which we partitioned into two, train and validate. So the first command here is we're creating, the first code here is we're creating an object called 3.1, okay, and it's from the function classification tree of the party package, where we regress our NSPF variable on the first three, okay, the first three variables. Of course, you can, if you want to include all, okay, if you want to include all, then but that will take longer kasi maraming variables siya, no? And then data is equal to train. So we're using first the train data. Okay, then we printed it, then we plotted it. So let me just generate this. And then we were able to, okay, it's still running. So all the more, guys, if we included all the variables, it will take longer. Maybe in a while, let's do that. Not really all, kasi hindi natin it will not include the mean, the etc. Okay, so it's taking some time. All right, so we now have a tree object, and it's a large binary tree, 1.2 megabytes. Okay, if we print tree, guys, if we print tree, okay, so we have 10 terminal nodes. It means that there are 10 nodes at the end. So it's like just like a tree. When you have your root at the bottom, there are 10 leaves on top. Okay, so these are terminal nodes. Okay, and then the response variable is NSPF. The inputs are the three variables here: 1007. 18 observations, because we're using the train object. Remember, we split this, the train and the validate. We split cardio object into train and validate. So let's take a look at train. Train has 17, 18 observations. On the other hand, validate has 408. Okay, so that's the sum of the cardio object, 21, 26. Okay, so from cardio, we created two separate data frames. The train data frame, just to be sure, guys, okay, just want to make sure that you understand that. If we view train, okay, right? So it's the same object as cardio. However, it has reduced number of rows. Okay, and in fact, as I pointed out a while ago, it includes row 1. Okay, wait. It doesn't show here. It only shows the number of 1718. Wala bang ID to? Okay, walang ID. So we cannot specify here or show here that this is respondent 1, 2, 3, 3, and then I think 5. Diba? Tama ba yun? Ang PD natin, ayan o, 1, 2, 3, 4. So the first 4 will go to the trained data set, and the fifth respondent observation will go to the validate. Okay? Okay, so we printed the three object. Okay, so we can read this, guys. We can read this, and medyo mahirap nga lang siyang basahin pag ano, no? Sabi here, we start with AC. Okay, so ito yung pinaka-importanting variable sa atin. AC, if it's less than 0.008, wait. Pareho ba siya ng R party? Criterion 1, statistic 263.403. Okay. Less than 0.0083. Okay, criterion 1. So if it's less than 0.0083, di yata. Wait guys, I think there's another way to read this. I'm not sure. Okay, there are 19 kasi nodes natin, ano? Okay, so let me first plot this. Let's use the plot of 3.1. Guys, just a moment, dali lang. Okay, so let's plot this. Hindi natin kasi na-discuss tong yung descriptive ng tree. So AC, we said if AC is less than AC is less than 0.001. If AC is less than 0.001, then you go to LB. Okay. Saan napunta yung kanina yung number? Category 1. Okay. Let me go back here. AC less than 0.0083, criterion 1, LB less than 136. 4 is a terminal. It's a terminal node kasi may asterisk siya. 5 is a terminal node. 7 is a terminal node. Okay. So it's so difficult to I didn't study, guys, how this is interpreted. It's easier to interpret yung sa R part na package, no? Sa party, okay, ano ba tong 0.0083 na to? Can you please take a look, guys? AC less than or equal to 0.0083. Criterion is equal to 1. So this must be normal. And then the statistic is 263.403. Okay, so guys, I think I'll need more time to really decipher this. Sorry about that. I normally don't look at this, itong print, no? I just, what we're sure is that, ilan yung nodes natin? How many nodes do we have here? What am I running? Ito. So 17, no? 17 nodes all in all. Okay. This one, sorry guys, I was running the wrong the wrong code, no? Ito dapat yung print 3.1 dapat yung rinan ko. So there are 19 nodes here. No? So na makikita natin ang 19 nodes to, guys. The ones with the asterisks are the ones that are terminal nodes. So if we count this, C4, C5, C6, C10, C11, that's already 5. Okay, C12, C14, and then 17, 18, 19. Those are the terminal nodes. Okay, the rest are decision nodes. Okay. Did you see 0.0083, guys? Nakita nyo na ba kung saan siya? Tignan natin yung probabilities dito. 0.00083. 0.00083. 0.00. Okay, I think, guys, ito yun, no? Kasi naka-ano lang siya, tama. Okay. I think my analysis a while ago is correct. Kasi naka-truncate lang to, no? It was rounded off to 3 decimal places. So decision, ano kasi yan, ano? Decision node. Okay, let's go here. Let me backtrack a bit, no? Okay, ito. Okay. So dito, it's saying that if AC is less than 0.001, 0.00083, actually that's the number, but in our print, it was only 0.001, okay? Then you have criterion 1. Okay, criterion 1, statistic 26.403. And then we have here node 2. Okay. So pupunta siya sa criterion 1. Okay. So it's a bit difficult, guys, to okay, criterion 1. So ito yung mga criterion 1, no? It's a bit difficult, guys, to follow it from here. Okay? Pero yung second node, LB136, ito yun. LB less than 136. Okay, again, why don't I, para I don't keep on closing. So let me print this also. Okay, there, guys. No? So 136. Ito to. Less than 136. So it's here. It's here. LB less than or equal to 136, criterion 1. And then we have some statistics. 965, criterion 1, 965. Okay. So it's a bit difficult to follow through kasi ang daming data. Tapos mahirap i-visualize yung tree kapag ganyan, guys. As compared to this one, it's so easy to visualize the tree. Okay, so kitang-kita natin dito, no? So if AC is less than 0.001, but the actual value there is 0.0083, okay? Ito trinuncate lang, renound off lang to 3 decimal places. All right, so this one, guys, this diagram is the same as this. Pareho lang yan. Ito pictogram lang, no? And of course, it's easier to interpret this. It's easier to understand this compared to this text. Okay, na nakakalito, no? Nakakalito siyang sundan. Lalo kung malaki masyado yung tree, guys. Kung maliit lang yan na tree, mamaya mag-example tayo. Yung gamitin natin sa iris dataset. If the tree is short and if the variables are at a minimum, konti lang, then madaling i-understand yan, no? Madaling intindihan. Okay, then we said that we can prune the tree kung malaki by setting some parameters here. Pwede tayong mag-mini split. Minimum split. Okay. So what we did was we generated this model, di ba? Ang minimum criterion natin, 0.95. Okay, and minimum split natin 300. So let's run this. I'll run 3.1b, and I'll just print this. Okay, 14. So here you have 1, 2, 3, 4, 5, 6. 6 terminal nodes. Okay, and 14 nodes all in all. Ba? Okay, 14. 15 pala. 15 nodes all in all. Okay, of which 1, 2, 3, 4, 5, 6, 7, 8 are terminal. The others are 1, 2, 3, 4, 5, 6, 7. 7 yung mga decision nodes natin. Tapos yung 8 yung terminal nodes. Okay? So we were able to prune the tree, no? We were able to prune the tree and decrease the number of terminal nodes, no? Okay, so far guys, clear tayo. May ano, saan ba tayo natapos? Hindi ko kasi nalagay yung ano ko eh. Hindi ko nalagay yung notes ko, no? But I know which part we finished here. I wasn't able to put here the date kung saan tayo nag-stop. Please, saan ba tayo natapos, guys? Hello? Any feedback, please, kung saan tayo natapos? Chat. Misclassification. Okay, sige. Okay, sige, ituloy na lang natin to, no? Sa misclassification tayo, which is the next one. Okay. So here, guys, we can predict, no? We can predict, kasi nag-create tayo ng model, ang tawag ng model natin, 3.1b. 3.1b. Okay? So ang sinasabi natin dito, use the 3.1b model, ito, okay, and use the train data for it. No? Okay? So we're using, actually, how did we generate the 3.1b? We use the train model, di ba? Tama, guys? 3.1b, okay? Yung train object ginamit natin. So dito, ang papagawin natin, we will ask R this time to give us the predicted values. So we're creating this object P1T, okay? So we're asking R to predict using the 3.1b model, okay? This model, and then use it on the train data set. So let's run this. And then we have here view. Let's view this. So what will this give us? Okay, it will give us the predicted values. No? Okay, predicted values to. So ito 1, 1, 1, 1, 1, normal. Tapos 2 is suspect. Okay. Tapos, etc. No? Okay. In fact, now if we compare this, yung head ng train natin, okay, so crudely lang gawin natin to. I'm sorry about this. Head ng train natin yung first 6. Okay. So what do we have here, guys? Meron tayong P1T. Ang prediction niya na yung observation 1 natin ng yung train data set natin is normal. Normal. So lahat ng mga 1 na yan, guys, normal, no? Number 2 is suspect. But when we take a look at the actual train data, okay, doon tayo dun sa head. Actual train data, yung first observation natin is suspect, no? Second is, so dito mali tayo, mali yung prediction, mali, tama, mali ulit yung number 6 and number 7, di ba? Di ba, guys? Kasi yung according to the prediction, the first 9 elements are all normal. Pero based on our actual data, based sa actual data, suspect, normal. Okay, gawin natin yung first 9. Head, train, gawin natin 9. So first 9 elements of the train data set. guys, no? So first 9, okay, mali ito, no? Kasi ang prediction natin based on our model 1, 2 eh. Tapos 1 din to, 1, 1, 1. So ang mali natin 1, 2, 3, 4, 5. 5 predictions mali kagad, no? Okay, mali kagad kasi ang prediction natin based on P1P, yung first 9 yung first 9 dapat 1 lahat yan. Okay? Guys, do you get it, guys? We compared the predicted value. Again, ulitin ko to, importante kasi ito no? Itong predict function, guys, it will predict, okay? It will predict based on a model. Okay, so ang sinasabi natin dito, predict mo, gamitin mo yung 3.1 model. Ano yung 3.1 model, guys? Ito. Diba? Ito yun. If the AC is less than point, ganyan. Okay. Okay, sige, gawin. Okay, for purposes, guys, of illustration. Sige, para para naiintindihan natin. Okay. So let's take a look at how R is doing this. If AC is less than 0.001, pupunta kay LB. Then let's look at our actual model. Let's take a look at object number 1. If AC daw is less than 0.001, okay. Is AC less than 0.001, guys? Hello? Is AC less than 0.001? Yung unang respondent natin. Nagigets ba, class? Isa lang nag-chat. Answer ba to? Thank you, David. How about the rest, guys? Okay. What we're doing now is we're going through the prediction process, no? Anyway, 3 variables lang naman to, so madaling masundan to. Okay, number 1. Is AC less than 0.001? Guys, less than 0.001 ba si AC? Oh, yes, ito. 0.0000, di ba? Okay, so dito tayo pupunta, no? Kasi yung first observation, okay, dito siya, less than 0.001. Okay, tapos, pupunta tayo kay LB. Punta daw tayo kay LB. Is LB less than or equal to 136? Yun. Okay, LB is less than 136. Okay, ano susunod na gagawin? Punta kay FM. Punta tayo kay FM. Okay, is FM, ano ba to? Okay, so, dali ha. Dito tayo pumunta sa, is FM less than 0.00, saan na yan? Yung diagram natin. Okay. Is FM less than, greater than 0.112? Guys? Or is it less than 0.0012? So, saan dito pupunta, guys? Less than, di ba? Less than 0.112, less than 0.112. FM, no? FM, here. FM. So, dapat dito tayo. Dito daw tayo. Ang prediction niya, so dapat 1. Okay, bakit ang prediction niya? O, tama. Ito pala, 1, guys. Ito yung prediction niya, 1. Okay, do you follow, guys? Pero ang actual value niya, punta tayo dito kay asa na si train. Ang actual value niya is 2. Ayan, 2 siya. Pero ang predicted value niya, 1. Paano niya predict yung 1, guys? Ginamit niya yung model. Ito. It used this model. Okay? At tingnan natin sa number 10. Sa number 10 ba nag-agree sila? Just to highlight what's happening in our model. Ano ba observation natin kay train data? Gamitin natin si train data. Train data number 10. Number 10, ang actual is 3, no? Okay, kay train data, guys, ang actual is 3. Pero ang prediction niya dito sa P1T, ang prediction niya is 2. Okay, let's see, guys, kung paano nangyari yan. Okay, i-highlight ko ulit to. Okay, again, guys, punta muna sa AC. Yan ang unang pupuntahan. Observation number 10. Dito tayo, ha. Yan, ito. Observation number 10. Is AC less than 0.001? Yes, di ba? If it's less than 0.001, pupunta kay LB. So, punta tayo kay LB. Is LB less than 136? Yes, less than 136, di ba? Tama ito? So, punta tayo dito sa FM. Tingnan natin sa FM ngayon. Is FM less than 0.112? Okay, is it less than 112? Ano ba sa FM niya? 0 pa rin eh. 0 pa rin. So, less than 1.112. Therefore, dito siya. No? Okay. Ano ba yan, guys? Ano tong dito, guys? This is 1. 1 kasi 0.7711 yung probability na 1 siya. So, ang observation 10 ba natin? Kasi yung P1T natin. Bakit 2? Tama ba? 2 ang prediction niya sa number 10. Asan na yung train natin? Asan si number 10? Ang actual niya, 3. Diba? Observation number 10, ang actual figure niya, 3. Ang prediction natin dito is 2. Ang model natin, dapat 2 yung lalabas. Okay? Could you kindly, guys, could you kindly help me out on this? No? Okay, balikan ko tong train data natin. We're looking at observation number 10. Ha? Okay. Observation number 10. Okay, AC less than 0.001. 0.001 AC, check. So pupunta dito, no? Then we look at LB. LB ito. Is LB less than 136? Check. Pupunta dito. Tingnan daw si FM. Is FM, asan na si FM ito? Is FM less than 0.112? Check. So dapat dito siya. Dito. And this node, guys, si node 4. Si node 4, ang predicted value niyan 1 eh. Okay. 1. So dapat si P1T dapat 1 to. Eh bakit 2? Okay, could anyone comment, guys? Bakit 2 yung predicted value natin dito? Dapat 1 to. Tama ba yung pagbilang ko? 1, 2, 3, 4, 5, 6, 7, 8, 9. Tama. 10. Pang-10. Train data, yung pang-10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 3 dapat. 1718. 1718. Okay, I can see why. Okay, ang actual niya 3. Based on the model, dapat, are we looking at the correct model, guys? 16. Tama ba yung model na tinitin ko? What's this model? One B ba siya? Ay, 1B. Train. Tama. 1B. Tama, di ba? 1B. Now, dapat 1 din ang prediction niya doon. Bakit ganun? Predict 3.1B. So, ginagamit natin si 1B. Sino ba si 1B? Ito si 1B. Diba? This is 1B. So, susundin natin yung ano niya, yung decision rule niya dito. Pag less than 0.001, punta sa LB. Pag less than 136, punta kay FM. Pag si FM less than ano, dapat pupunta doon. Okay? So dapat ang prediction niya 1. But when we check P1T, ang prediction niya 2. Okay. So, dali guys ha. Ano lang muna, please help me out on, but that's how we look at the model. That's how we follow the model. Ganun lang siya guys. Hindi ko lang alam kung bakit nagkaka-error ako sa sa pag-determine kasi ito 0.711 eh. So dapat 1 to. 1, 2, 3, okay? Kasi pag 2, 9% lang yung probability niyan eh. So 0.711. Tingnan ko yung 4 ha. What's node 4? So itong 4, ano? 4 asterisk. So ibig sabihin terminal node siya. Weights 405. Pero hindi niya sinabi kung anong criterion 1. Criterion 1, criterion 1. Weights 11. Okay? So tama siya na node 4. Okay, terminal node may asterisk less than 136. FM less than 0.11. So ang decision, criterion 1 siya. Okay. Pumunta siya sa nodes 4 tapos okay. I think alam ko na kung paano ibasa to, no? Okay, yung pagbasa nito guys, by level. So first, okay, ito yung first path, no? 1 2 3 4, ito yung unang path. So 1, if AC is less than 0.0083, okay? So punta tayo kay LB. Then LB is less than 136, punta tayo kay FM. If FM is less than 0.11, then ang answer guys, criterion 1. Okay, criterion 1 yung answer. Yan na, tas terminal node na natin yan. So tumigil na tayo dyan, no? Okay, so flow pala to, flow. Sorry ha. Okay. Sorry guys kasi dati hindi ko pinapansin to eh kasi I just look at the diagram. So now we know, no? Ito yung flow na yun. Flow to. This is the flow. So 4 end na. Tapos na tayo dyan, no? Tapos na. Tapos ang total number of doon ang pumasok dito sa path na 1 2 3 4 405. Okay, if we take a look at our model, ito na lang. Okay, yan guys, 405. So that's the path. Ang path na yan, 1, 2, 3, 4. Tapos may path din na 3 to 5. Okay? So may path din na 3 to 5. Ang sinasabi ng 3 to 5, if FM daw is greater than 0.112, pupunta siya kay, ang criterion niya, 3. So terminal node 5. Okay, so let's show that. So that's, okay, so 1, 2, 3, 4, no? 1, 2, 3, 4. And then itong path na to, 3 to 5. Okay, so this is how the party package is presenting our decision rule. Punta naman siya kay 3, no? Babalikan niya si 3 kasi dito, may less than 0.11 tapos may greater than 0.11, no? So from 3 kapag greater than from node 3 kapag greater than 0.11, oops, terminal node na siya, node 5, no? Node 5 asterisk weight is equal to 11. So, hindi niya sinabi kung ano yung criterion. No? Okay, hindi nakalagay dito yung criterion. In node 5 kasi, ang pipiliin dyan is 3. 3 siya, 3. 001. This is the probability. The probability that it will be pathologic, that's 100%. Yeah. Okay? All right. So guys, ganun yung sa yung sa print ng natin ng model, sinusundan niya yung path, no? Okay, so ang pinakamalayong path dito, ito. Kung ita-trace natin guys yung print, may 1, may 7, may 9, may 11, may 12, or then 13. 1, 7, 9, 11, 12, 13. Tingnan natin yan. So, asa na yung 13? So, nagsimula na siya sa... Kasi nabanggit na natin yung no? Wait. Hindi ko abisado. 1. Tapos 7. Tapos 9. Tapos 11. Tapos 12. Tapos 13. Dapat terminal node yung 13. Ay! Ano ba yan? 1A yung tinitinan ko. Sorry. 1A yung tinitinan ko, guys. Shucks. 1B pala tayo. Ito yung guys, ito yung sinasabi ko nila. 1, tapos 7, tapos 9, 10, 11, 12, 13. Yun. Yung path na yan, yung path na yan. Okay? So that's how you read the path. May 1, 7, 8, plus terminal to. Tapos mayroon din 1, tapos 7, 9, 10, another terminal node. Tapos mayroon din 1, 7, 9, 11, 12, 13, another terminal node. Ito kasi yung pinaka, niya, simula 1, 7, 9, 11, 11, tapos punta na tayo sa 12 na to, tapos 14. Okay. Alright, so that's how you read it, guys. No? That's how you read it. Pero once again, guys, nice to know, pero para sa akin yung plot na lang kasi medyo mahirap sundan yung in fact, to be honest with you guys, I never really looked at this. No? And to be honest with you, now ko lang na-discover kung paano binabasa yan. Kasi I didn't put much attention to that. I guess I'm more visual, no? That's why ang tinitingnan ko yung visual. Kasi mas madali nga na maintindihan to, no? Kaysa dun sa numbers na titingnan mo pa. Okay? All right. Questions, guys? Questions so far? Questions? Naintindihan kung paano binabasa tong print? I didn't really plan, guys, to read this now. Wala talaga akong kaplano-plano. Kaso, I thought na gano'n lang siya kasimple, pero hindi pala. No? Kailangan talaga iti-trace. No? Okay, so that's the path, guys, given to us by the model. Okay, any questions about the printed model? Okay, good. Thanks. Sana nakuha din ng iba. How about the rest, guys? Okay, pero sa assignment nyo, guys, I won't ask you to, of course, I won't ask you to interpret that. Yung plot ang gamitin natin kasi ba't natin papahirapan yung sarili natin. Okay, so balik tayo dito. No? So here, we're saying that this one, itong predicted value na to, we use this object, it's a vector of one column. Okay, it's a vector, so isa lang siya. Predict yung 3, sorry, it's not a vector, it's it's not a vector, it's a data frame, no? One column lang. So we use the predict function. Okay? And then anong model daw gagamitin? Si 3.1b, yung 15 nodes na yon, no? And then gamitin kay train. Okay? So and then we view the P1T, the predicted value. Okay? And then ngayon, now that we have that, guys, now that we have P1T, ito, gagawa tayo ng table. I-compare natin yung kay train, ito. Yung actual value ng NSPF, okay? And yung predicted value natin, ito. So we can put them side by side. Kasi parehong ano yan, parehong rows, 1718. Kasi di ba dito predict natin si train mismo. Tapos dito yung actual value ni train. Okay? Check lang natin, guys, dapat 1718 lang yan. So we can construct a table. So dito marami nagkakamali, guys, pag gumagawa ng table. Minsan, nagko-construct ng table na yung isa data frame na isa lang, tapos yung isa naman data frame na 5. So magkaka-error tayo doon. So make sure na pareho yung ano nila, pareho yung number of observations at saka yung columns, no? So we're going to create this will be our y-axis. Okay, ito yung x-axis natin. Okay? So we will put in the y-axis yung predict 3.1 dapat dito, no? Yung B ang gamitin natin. Okay, sige, okay lang to, guys, no? Kasi may 1A din tayo eh. Ano ba yung 1A natin? Sige, compare na lang natin si 1A, no? Si 1A natin, tingnan natin kung sino mas maganda. Si 1A, ito yung may 19 nodes. Okay, or si 1B yung may 15 nodes na lang. Okay, kay 1A, guys, sino yung ginamit natin na na sa model? Ang ginamit natin na model yung kay train, okay? Tapos kaso wala tayong predict na wala pa tayong predict na value from 1A. Okay, saan na yun? Okay, guys. Ito. So sabi natin kay okay, subukan nyo nga i-run. Mararan ba natin to, guys? Can we run this? Yes, okay. So ano nangyari, guys? So dito, sabi natin, mag-create siya ng table, no? Itong function na to table. Now on the y-axis, you have the predicted value using 3.1a. Tapos yung pangalawa, yung actual value na train, okay, train data, yung column lang na NSPF. Okay? So here, isang column to, ito isang column. So okay 'yan, pwede 'yan. So let's see, ipa-print natin yung table.1a. All right. So what do we have now? So the table will now isa-sum up niya kung ano yung magkakapareho, no? Okay, so what do we have here? On the y-axis, you have the predicted value. Okay, on the x, you have the actual. Kasi yun ang yung una dito, siya yung magiging nasa y, yung pangalawa, siya yung magiging nasa x. Pwede rin pagpalitan, guys. No? Kung gusto nyo yung nasa y, yung actual, okay, dito lalabas yung actual, tapos dito yung predicted. Pakita ko lang just to be, just to be, pinopya ko ba? I'll call it 1AA, no? But this time, ilalagay ko, guys, si actual dun sa y-axis, tapos yung predicted dun sa x-axis. 1. Okay. Okay, what's the difference between this? Okay, just to distinguish, ito yung 1A natin, di ba? Yung nasa y-axis natin si predicted, tapos si actual nasa x-axis. Kasi sometimes you might want the actual here. Okay, so depende dun sa kung ano gusto nyo. Bagal talaga sa ano sa inyo guys? Nag-generate na ng output?
Loading.
Loading pa rin, sige. Sana dapat umabot tayo sa R part, no? Tagal lang. Okay, yan. So guys, yan actual predicted. So depende dun sa kung saan nyo gustong ano. Okay, lagyan ko na lang to ng again, actual on the y-axis. Okay? So anyway, okay, ito lang i-ano natin guys. Ito na lang i-analyze natin. So okay, so here guys, okay, actual 1298, predicted 1298. Okay, so ito yung tama na predict natin na number 1 siya, na normal. However, may predict tayo na 50 siya when in fact, ano siya, ang actual value niya, normal. So may mali tayo dito, no? Okay, so si model natin, si 3.1a, nag-predict na number 2, pero dapat number 1 siya. So mali ito. Okay? So ang mga tama lahat dyan guys, yung mga diagonals. All the diagonals are correct. Kasi 2 to 2, 3 to 3. So yung mga errors natin, yung mga off diagonals. Dito, actual, ang actual niya guys, number 2 dapat siya, pero predict siya as number 1. Okay, so maling prediction ng number 1 to. Okay, so 130 observations were actually 2 and it was predicted as number 1. 100 observations were predicted to be 1, okay, but it was actually number 3. Okay, 50 observations were predicted to be 2, pero 1 lang 1 siya dapat. So ito din mali, no? Predict na 2, pero number 3 siya dapat. Okay? Kay 3 lang ang walang error, no? So lahat ng predict na 3 tama siya, no? Walang predict na lahat ng 3 predictions, okay? Okay, lahat ng lahat ng predict na 3 guys, 11, no? Tama siya, no? Okay? Tama ba 'yan, guys? So ito kasi predict na 1 pero 3 naman talaga siya. So mali ito, no? Predict na 2 pero 3 naman talaga siya. Ito predict na 3, okay? Pero hindi na pero 1 naman siya, walang ganun. Predict na 3 pero 2 naman siya, walang ganun, guys, no? Predict na 3 tapos 3 naman talaga siya, 11 yun. Okay, so that's what this means. Walang error sa prediction na 3. Okay, pero may error sa prediction na 1. Ang error na predicted na 1 is 130 at 109. Ang error dun sa predicted na 2 is 50 at 24. Okay? So we can actually compute for the we can now compute for the percentage of correct predictions, no? Paano natin mako-compute yung percentage of predictions? Gagamitin natin yung sum ng diagonal. That's a function. Sum ng diagonal function ng table natin. So this is the diagonal. Ito yung mga correct, no? 1, 2, 9, 8, 96 at saka 11. Okay, so that's the diagonal of table 0.1a. And then isa-sum natin yung lahat ng elements ng table 1.1a. So that's 82% correct. Therefore, 1 minus that should be around 18% wrong. Okay, so yun ang ano natin, yun ang performance ng ano natin ng 3.1a. Okay? 3.1a. Okay. Oops, sorry, mali. All right. So let's go now to let's also see the misclassification error for 3.1b. Tingnan natin, no? So again, magka-create tayo ng table. Okay? Yung predicted natin, yung y-axis natin, ito naman gawin natin yung y-axis. Ang ginagamit natin, yung predicted ng 3.1b. Ang actual natin, yung train ng NSPF. Remember guys, yung predicted value ng 3.1b, okay? Yung predicted value nito, it's one column, no? Yung train $NSPF, it's also one column. So let's see, let's print this. Okay? So once again, may mga error terms tayo. Tama ito, no? Tama. Ang mga errors natin, 126, 70, 101. Okay? So let's get the percentage correct and percentage wrong. So 81 at saka 19. So it turns out guys na mas mataas yung tamang forecast dun sa 3.1a, no? Compared to 3.1b. The reason there is that guys, yung pre-noon natin kasi si 3.1b, no? So mas prone yan sa error talaga pag generalize natin masyado yung classifications natin, no? Okay, so let's move on guys. Kasi nga nag minimum split tayo. Tinaasan natin in other words, mas kokonti yung natin yung terminal node. Okay. Okay, now guys, pupunta tayo ngayon sa gagamitin natin ngayon yung validate data set natin. Now that's the reason why we split the data, kasi gusto natin na meron tayong data na hindi pa nagagamit, hindi pa nakikita ng model. Okay? So we have a trained data. Yung trained data na yan guys, nakita na ng model yan, ginamit na ng model yan natin. Ginamit na ng train.1a yan, ginamit na rin ng train.1b. Okay, so now we're going to introduce a new data, yung validate natin, yung consisting of 800 something, ilan yun? Okay, which is not found in your trained data. So gusto natin tingnan kung yung kung yung model natin okay pa rin siya. Okay, using a new data set. Okay, so we're here creating P1 validate, sa validate natin to, no? Kanina P1T yung training natin. So we're going to predict, guys, using model.1a si validate data natin, no? Okay? So let's see. Prediction natin. Okay, pag dito guys, ang bibigay sa atin yung mga yung mga classification. Pero pag dito naman guys, iba yung bibigay nito. Pag probabilities ang gusto natin, okay, take a look at what this will give us. Okay, probabilities ang ibibigay sa atin. Medyo mahaba nga lang, pero tingnan natin. Okay. But they actually give us the same output. Yun nga lang ito. Kunyari ito. Okay. So this is the first observation kay validate. And the probability that it's normal, 98%, 0.4% lang na suspect siya at saka 0.6% lang na pathologic siya. So 1 to, no? 1. Diba? Tingnan nyo guys, 1. And dito sa natin, dito sa walang type is equal to probability, 1 yung answer dyan. Okay, so ito binigyan na ng probabilities. No? It just gave us the probabilities. Any questions dito, guys? Okay, umabot tayo sa our part. Any questions about now using the validate data set? No? Ginamit na natin yun yung validate data set. So sa assignment nyo guys, hindi assignment, sa first quiz, okay, make sure to partition your data. Huwag nyo gagamitin lahat. Okay. Alright, so let's move on. So tingnan natin guys kung kamusta naman yung ano natin. Kamusta yung paggamit natin ng model natin na 1A dito kay validate data set natin. Let's see. Okay, so again, we're creating a table. Parang ganun na din guys. Piprint natin yung table natin. Si predicted natin. Okay. Predicted is equal to P1V. Okay lang yan guys kasi may P1V na tayo dito. No? Okay. And then actual, check ko lang to Check natin check na natin lahat. Okay, ba't tayo nag-error guys? Bakit tayo nag-error? Kasi ang P1V natin dito guys is ito na, yung latest sa P1V natin, yung list na ng probabilities eh. So, gawin natin itong underscore prob, no? Para i-run ulit natin to. Tatanggalin ko na yung tanggalin ko tong parenthesis, guys. Kasi ang binasa na niya sa P1V, guys, yung probability list na yun, di ba? Dapat pag i-compare natin sa validate and SPF, dapat isang column lang yun. So, yung mga nuances, guys, so take note. I-run natin to para ang P1V natin ulit yung isang si P1V, just to be sure, tinan nyo. Parang si P1, ano din yan kanina, no? P1T, yung training natin. First P1V, ito, no? P1V, okay, 3 levels siya guys, okay? Yung 1, 2, etc. If you want to print that, okay lang, i-view natin, no? Parang hindi ko na gaganon guys, ha? Okay, so we can now run this, pwede na to. Okay, kanina guys, nag-error kasi, again guys yung P1V natin kanina, yung pangalawang P1V, probabilities na yun, di ba? So nung ginamit natin siya dito, nag-error na kasi hindi na pareho yung size ng natin, ng validate at saka ng predicted value natin. So this will now run, okay na to. Kasi pinalitan na natin okay. So 0.2, 0.8.2, halos pareho lang. Tingnan niyo guys yung kanina yung train data set natin, nung ginamit natin, 'di ba, yung 3.1A natin, 'di ba, 80% yun 80% ba o ano? So dito nung ginamit natin sa bagong data, okay? So ang mga 80% yung tama, yung diagonals 126, 196, 291, may mga error. So 80% guys, 80% nung ginamit natin yung model sa isang bagong data, okay, not bad kasi halos pareho lang siya dun sa training model natin. No? Okay? And then, as part of your exercise, subukan nyo rin guys si 1B, no? 3.1B. Okay? Gamitin natin si 3.1B model in order to see yung performance siya using the validate dataset. Okay. So we have 20 minutes, kaya natin to. Alright, yung next guys, yung next na na gagamitin natin na package. Kanina, party package. This is another package. Meron pang fast and frugal tree, okay? In decision tree. Tapos ito naman yung rpart package. So, paki-install nito guys. Sana na-install nyo na, tapos i-access na lang natin. Si rpart at saka si rpart.plot, this is used for plotting. Okay, sige. Tingnan natin to. Okay, parehong data guys Parehong data. Let's see kung ano mangyayari. So we're now creating a new model 3.2 using rpart. Rpart naman ganun din guys. We're regressing it against these 3 variables using the trained data set. Tapos print natin si 3.2. Okay, control enter. All right. Okay, so what do we have here, guys? parang pareho lang kanina ng parang pareho lang kanina ng party package. Medyo magkakaiba nga lang yung nila, no? Pero dito pareho yung yung terminal node, no? So si terminal node 2, si 12, si 13, si 28, node ba to? 29, okay? 30 at saka 31. Ito yung mga terminal nodes. And then again, ite-trace lang din guys, no? If AC is less than 0.0084, okay? So dun sa node na yan, ito yung probabilities, tapos ito yung number of observations. Okay, so hindi na natin titingnan masyado yan. Tumingin na tayo guys dito sa, we're going to use now the other package, yung rpart.plot. Okay, so titingnan natin yung yung probabilities for NSP. No? Run natin to yung pangalawa. Okay. For me, the diagram here is better kasi may kulay pa nga siya. Okay, di ba? Sino sa inyo mas gusto tong diagram na to? Yung R part kaysa dun kanina sa sa party package. Paki-chat nga guys if you prefer this. Mas presentable siya, di ba? Mas siya, mas at saka mas madaling maintindihan. Okay. Alright, I'm sure yan, mas malinis. Okay, tama, no? Mas presentable. Okay, so at saka mas madaling to, no? Okay, so magsa-start node 1, okay? Magsa-start sa AC. If it's less than 0.000396, no? Yes, punta dito kagad. Okay, so iba yung nila, no? Iba yung model nila, no? Kasi kanina AC, tapos pupunta sa LB pa muna, tapos pupunta kay FM. Ito hindi. Pag less than 0.008396, punta kagad kay punta kagad kay normal. Tapos pag no, guys, wait, sorry. If it's greater than pala to, no? If it's greater than 0.008396, then pag yes, normal kagad yan. If no, pupunta din sa LB, no? Kay LB. Tapos if LB is ano ba to? If LB is less than 137, yes yung nasa left, no yung nasa right, no? Is LB less than 137? If it's yes, punta tayo kay FM. So si FM magbabranch yung pangalawa. Titingnan natin si FM. Is it less than 0.2? Punta ka dito. 1 yung result. Otherwise, punta ka dito. 3. Okay? So ganun din. This is your decision tree, guys. Using the rpart package. Okay? So, yung niya guys, yung mga okay, ito guys, itong color na to, this represents yung 1. Okay? This one, dito natin, no? Dito, this represents your 2. And then yung green, that represents your 3. So, 3. Okay, clear yan guys? Clear yung plot natin sa rpart? Sige, so now, sa plot guys, pwede natin ilagyan ng extra yan, no? Okay, ito. Just for us to rpart.plot. Check niyo yung yung syntax. rpart.plot. Let's wait. It's always helpful. It's always useful to check. Hintay lang natin. Tapos, okay, I'm going to send, papakita ko na lang. Kanina ginawa ko yung sa iris dataset. As an exercise lang for you guys, try doing that. No? Anyway, may pattern naman kayo. Okay. So while we're waiting for the rpart, okay, meron ako ditong ginawa kanina. Asa na yon? Ito guys. Okay. Gawin nyo to gawin nyo to. rpart din. Ang data na gagamitin guys, iris dataset. So si iris, it comes with the datasets package. So you can easily access that. Si iris. Tapos ganun din guys, nag-set.seed ako, no? Kasi si Iris ang asan na yung data ko na Iris. Nandito pa ba? Okay, practicein nyo to, no? And then I will only give you the answers, guys, if you show me, okay? If you show me that you did it, no? Pag hindi nyo ginawa yan, guys, hindi ko papakita itong ano. Kasi ibig sabihin nun, hindi naman kayo interesado. Okay? Ito yung Iris dataset. Tagal. Ang bagal talaga ng computer ko ngayon. Ano pala? Wala si R part. Sandali ha. Ang dami tuloy nag-Iris. Tuloy-tuloy. So Iris guys, ito yung ano natin, ito yung variable sepal.length, sepal.width. A very classic classic data case. Ang gagawin natin dito, i-regress natin si species, okay, on these 4 variables. Okay, regress natin si species. Gusto natin ma-predict si species using these 4 variables. Okay, so decision tree din ang pwedeng gamitin, no? And then actually guys, kung tutuusin, you can do regression on this. Regression, predict natin. Ano nga lang, this will be multinomial kasi ano siya, yung categorical variables. Tapos marami siya, tatlong classifications ng species. So hindi natin pwede gamitin si logistic, binary logistic kasi si binary logistic dalawa lang. So itong multinomial regression. So pwede natin i-compare eh. Paano kung mag-multinomial regression tayo or paano kung mag-decision tree? Since ma-measure natin guys yung classification, yung confusion matrix, malalaman natin kung sino mas magandang model. Kung yung multinomial regression ba o yung decision tree. Okay? Siguro ang gagawin ko guys, I'm going to share with you yung multinomial regression nito. Sundan nyo yon, tapos makikita natin dun yung confusion matrix natin, ilang percentage yung tamang na predict. Tapos i-compare nyo sa decision tree. Okay? Either you use yung party package or yung R-part package. Okay? Ito guys, yung R-part package, ito na. Yan. So may mga types siya, no? Type 1, 2, 3, 4, 5. Tapos may extras pa, no? May extras. Extra, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Tapos plus 100 pa. Ibig sabihin, 101, 102, 103, hanggang 111 extras. No? Okay, so I want you to explore that. Okay, so asa na tayo? Okay. Sorry guys, medyo napapamadali ako. Tinitingnan ko yung oras, magpo-4 na. Dapat makatapos mo lang tayo nitong asa na ako? Asa na yung model ko? Okay, ito. Yan. Alright? Okay, ito yung sinasabi ko guys, no? You can plot it. Pwede kayo maglagay ng extra. Okay, extra is equal to 1. Extra is equal to 2. Extra is equal to 3. Extra is equal to 4. So, tingnan nyo na lang to guys, ha? Experiment nyo kung ano yung differences nila. Okay? So, pwede rin extra is equal to 101. No? Kasi 100 plus 1, 100 plus 2, etc. Alright. So, mag-predict na tayo guys. Predict natin yung 3.2. Okay, yung model na to na 3.2. Ano ba yung 3? Create muna tayo ng P2, no? P2. So we create an object called P2. We're predicting 3.2 from the train package. Okay? Yan. Okay, kaso ito guys. Kaso ito, probabilities ang binigay. So paano yun? Dapat ano lang, dapat number lang. Hindi natin pwedeng hindi tayo pwedeng gumawa ng table nito, guys, kasi si P2 data frame na 3 di ba? Ayun 3 columns Tapos i-compare natin siya dun sa ano sa train na NSPF. Okay? So dapat alam natin to kasi dito maraming nagkakamali. Control C, Control V. P2A na lang gagawin ko para magkaiba. Then type equal to, dapat ilagay natin to, no? Plus. Yan. Okay, so I'm creating now P2A, pero sinama ko tong P2 type is equal to class. Alright, so ano na to? Yan. Factor na siya, no? P2A. Factor na siya. Ayun na yung mga 111, 111, etc. No? Guys, are you getting it? Guys? Pag i-view ko to, view. P2 P2A. Yan, pwede na, guys, no? Okay, so careful lang kayo, guys, pag nagpre-predict kasi minsan nagkakaroon ng ganyang ano, depende sa ano minsan sa package na ginagamit. Kasi here, yung ginamit natin yung package na ano, yung 3.2, ginamit natin si rpart, di ba? Kanina ginamit natin yung ano, yung party package, wala naman tayo ganyan na problem, di ba? Hindi naman natin linagay na type eh. Di ba? Hindi natin linagay na type. Pero dito sa rpart, na-notice ko na, you have to put the type. Otherwise, magkakamali tayo. Alright, so okay na yan, ano? So dito dapat P2A tayo dito. P2A, okay. Tab 2, okay. So we can now see this, guys, yung confusion matrix natin, yung ano natin. Alright, here. Okay, ito yung mga tama, ito yung mga mali. Okay, so let's see. Asan yung ano natin? Okay, copying ko na lang yung code ng ano ng pag-compute para mabilis, no? Control C. Okay, I'm copying, guys, this. Okay, may confusion matrix na tayo. Kaso ito dapat maging ano to? Tab 2. Para dito sa table na to. This one is also tab 2. Kasi ang pangalan natin dito tab 2 eh. Tapos tab 2. And then tab 2 din. There. Okay? So, run natin to. Lahat na. Okay. Oops, 83%, no? 17. So, ano ba yung dati kanina? Yung 3.1a, ilan ba? Yung confusion matrix natin, ilan ba yung ano? 81 lang, ano? Di ba? 81 lang ba? Ito. 82. Okay, 82, 18. So you notice, guys, na we're using the same data, di ba? Using the same data yung train din, pero yung R part natin, mas ano siya, mas mataas pa yung ano, yung model na 3.2 natin, mas mataas pa yung ano niya, yung batting average kasi 83% yung tama eh. 17, no? Di ba? Okay? And then last dito, meron lang dagdag dito na ano no na hindi ko na nasalit to, no. Sorry, hindi ko nalagay. Okay, let me finish this kasi pwede natin lagyan ng control to eh, no. Hindi ko pa nalagay dito. Okay, so don't mind this first. Okay, and then I'll just send notes dun sa dulong portion na to, no. Okay, so let's quickly summarize, guys. Decision trees are very important because they can be used to predict values, no. Parang regression lang dati niya yung guys. Pine-predict niyo yung values ng quantitative variables and qualitative variables. Pero pwede rin siyang gamitin sa quantitative. So dito, ang ginagamit natin sa kanya yung qualitative variables. Mas mahirap gamitin to sa quantitative variables. No? Okay, so dalawang package ang ginamit natin, yung party package at saka R-part package. Okay, na-notice natin na si party package, yung sa unang model natin, yung 31A, it generated yung tamang percentage ng prediction, 82%, mali 18%. No? Okay. But before that, guys, sabi natin, we do not we do not model everything, all the observations. Kailangan mag-split tayo. Mag-split tayo ng pang-training at saka mag-split tayo ng pang-testing. Usually it's 70-30 or 80-20, 75-25. Wala namang hard and fast rules. But usually ganun yung range na depende kung malaki yung kung malaki yung data set, okay lang na mag 60-40. No? Pero kung hindi masyado malaki, 70-30, minsan 75-25. Okay? So, we use two packages, yung party package and then yung R-part package. We can use both for decision trees. Meron pang isang package na titingnan natin next meeting. Pero matagal pa yun, guys. So, ang gagawin ko doon nga pala, sorry, ang gagawin ko doon is that I'm going to record that, yung fast and frugal tree na package. Iba naman yun, no? Tapos iba din yung mga features niya. So at our disposal, guys, we have several packages that we can use for decision tree. Okay? Now, yung assignment ko, guys, ipopost ko yung instructions and that is due for, kasi parang exam yan, guys. Okay, kailan due yan, guys? Next Friday, okay na kayo? Hello? Next Friday ba? Pwedeng due na yung quiz yan, guys, ha? Quiz yan. So most of our quizzes will be like this, guys. Hindi tayo mag-aano sa synchronous. Okay, you're a small class. Okay, gusto ko na talagang hanap ng data, i-apply yung mga models na nagagawa natin kasi hindi natin mahirapan tayong gawin yan sa pag synchronous tayo. Okay, any questions, guys? Any questions? Again, balikan ko tong sorry, any questions ako tapos hindi ko kayo pinapag-question. Yan, ganun din, guys, yung iris dataset. I-practice nyo to, no? Tingnan nyo kung ano yung kakalabasan ng model using the iris dataset. Hindi na mahaba, guys, eh. Kasi R-part lang naman ng kung gusto nyo, gawin nyo rin yung gawin nyo rin, guys, yung party package para ma-compare nyo, para practice, no? Okay. At ito, guys, tingnan nyo, P2, no? Predict. So sinasama ko yung type is equal to class. Kasi kung hindi ko isasama, tatlong ang i-generate niya na P2, tatlong columns. So it's a data frame of 3 columns and hindi natin pwedeng i-table 'yon, no? Kasi si P2 tatlo tapos si actual isa lang, mag-error tayo. Okay, so any questions, guys? Did you learn anything today? May natutunan ba? Kahit papaano, guys? Yung totoo lang, may natutunan ba? Interesting ba tong machine learning, guys? Okay. Konti lang yung sumasagot. Parang wala natutunan, Stop ko na pala yung recording.